Hi there, this is Thomas speaking from investmentexcel.com. In this session I will briefly introduce you to pricing of a non-callable and a callable cash flow structure. We will look at the present value, the set spread and the option adjusted spread. This session serves as an introduction to the more advanced pricing method techniques that we demonstrate in other sessions on mortgage bonds and callable mortgage bonds, models where we implement both a stochastic interest rate feature and a prepayment function feature. But in this session it will all be very simple, hopefully. This video and the Excel workbook and the underlying VBA programming codes are available on investmentexcel and spotafile.com. Let's start by looking at the cash flow. Needed info up here in the upper left corner. 5 cash flows. Expected payment of 20 at each cash flow, 5 years to maturity, so leaving 1 cash flow a year. We have a market price of 80 of this cash flow, given that there is no optionality in terms of leaving the borrower with a prepayment option. On the other hand, with this prepayment option, this optionality to prepay the notional amount earlier than required in the or scheduled in the initial cash flow structure is 75. If we price this cash flow on the government bond risk-free curve with zero coupon yields, it's 85. So obviously already now we can see that there is a discount on 80 here compared to 85. So obviously the borrower in this case is not the state, it's not the borrower behind the risk-free rates, and the 75 is another premium compared to the non-callable structure. So the 5 from 85 to 80 is a credit or liquidity risk premium. 75 compared to 80 is pure optionality premium, prepayment premium. Alright, let's look at the cash flow structure. And this is the non-callable structure. You see the 5 times $20 expected to be paid out according to the inputs. We have the government bond risk-free curve, all zero coupon yields. We have no spreads, and here we have the discount factor. So discount factor as usual being calculated by 1 divided by 1 plus the corresponding yield raised to the power of the majority, and here's the price for each cash flow in present value terms. Summing all present value terms gives 85, which is correct. It's also stated up here because that is exactly the risk-free pricing of the cash flow. So it can be interpreted as a price that investor will pay if he only requires the risk-free rate, i.e.